All right, so we're just going to take these formulas for a geometric sequence, and we are going to use them on the setup of the problem. So we need to translate the setup of the problem into the symbols that we know and use within the formulas, and then we're going to put them in the formulas. We're going to solve for some variables, and then we're going to, if we need to, we're going to regurgitate it again in a different formula and give it a go. So find the eighth term of that sequence. Well, okay, for the record, this sequence, you can multiply it by 6 each time, right? That's the ratio. The common ratio is 6. And there are 5 of the terms that you, from the sequence. You're looking for the 8th. So I guess technically you could just multiply by 6 3 times to get the 8th. But if I make that like 1.5 million, you would then need to use the formula. So we'll just use the formula. So we're going to do find the 8th term. So it's a sub 8. That's what we're finding. A sub 8 refers to the value of the 8th term, or what the 8th term actually is. A sub 1, we can get that straight from there, which is 2. R, which we already found, was 6. So R is 6. And to the n minus 1 power, or 8 minus 1. That makes sense? By the way, one thing that you're going to really want to do, or you think you should do, is you're going to do 2 times 6. That would be really bad. That's not paying attention to the order of operations. Okay? The order of operations says you do the exponents first. So do the exponents first. Please don't multiply those two things until you do the exponent. So you get 6 to the 7th times 2, which is what number? When you guys get that yet?
The answer?
Yeah.
559,872.
Is that right? Should I do it? Yep. 72. Okay, so there's the answer for that one. Again, that should feel really similar to the arithmetic sequences that we've done already. It's just a different formula. All right, next. Let's start pulling out the information. Find the 4th term. So we're looking for a sub 4. That's a question that comes out of that statement. Of the geometric sequence, you need to, when you read that, you need to think of this. By the way, for the record, you will get all these formulas for your quiz and test to soothe your anxiety a little bit. Surprise. Sequence that has 1024 as your 7th term. This part of the statement says a sub 7 equals 1024. And a common ratio of 4. That means R is 4. So we just translated all the wording and all that setup into the symbols that we're going to wind up using. And we're going to put that, let's start putting stuff together. So a sub 7 is 1024. We have an expression that talks about geometric sequences. So we're going to eventually use that. But if you didn't know that you were going to just use that right away, and you were thinking, okay, what's a sub 4? I'm going to put a sub 4 in. And you started putting things into the, the ratio is 4, so we write that there. And then you do 4 minus 1. If you start doing the problem right away, just by putting it into the closed form or the rule for a geometric sequence, you get stuck because you don't know the first term. So you got to go about finding the first term. That's the reality. So what we're going to do is we're going to take this, put it back into this equation, and we're going to see if we can get the first term from that. A sub 7 is 1024. That means the a sub n part is 1024. With the statement a sub 7 equals 1024, that means a sub n equals 1024 when n is 7. So we get that statement, but we have a rate. We know what our rate is, so that rate's actually 4, so we're going to put 4 in there from the problem. Then we see if we can solve this. That becomes 4 to the 6th power. I don't know what 4 to the 6th power is. What is it? 4 to the 6th power is 4,096 times a sub 1. Then divide by 4,096 and you can find the first term, which becomes, what does it become, 1/4? Right? You get a sub 1 is 1/4, then you take that, and now we solved for that variable, and we're in good shape. So a sub 4 equals 1/4 times 4 to the third power. 4 minus 1 is 3. Now here's another issue that you might do. You might do 1/4 times 4 because you think that you're supposed to multiply those together right now. But you would be ruining the whole order of operations. So don't do that. Follow the order of operations when you're doing these problems. This would wind up being 4 to the second, which is 16. Okay? Any questions? Okay? All right, let's do the hard one, number 3. So let's first pull out the information we're actually looking for, and then we'll respond to it. We want to know the common ratio. Okay? We want to know the first term. Okay? We want to know the third term. Okay? We know that it's a geometric sequence. We know geometric sequences are that. Okay. This statement right here, a sub 5 equals 162, that means that when n is 5, a sub n equals 162. All right. And then similar with a sub 7. So we have an issue. We have an issue that we're looking for all the important parts of this. Okay? So we can't do anything right now. Although what we can do is we can go back to here, and this gives us information. When we match it up with that, we can get a setup. So let's start putting in information. When n is 5, a sub n is 162. So a sub n is 162 when n is 5. And then if you simplify that a little bit, you get 162 equals a sub 1 times r to the 4th. Okay, you get stuck there because you don't know what a sub 1 is and you don't know what r is, so you're kind of stuck. But we got somewhere. That's a benefit. We also have more information written down for the problem. We also have that. So we can turn around and mix that again, regurgitate it, and mix it again with that, and see if we get somewhere new. Okay? And hopefully we'll get somewhere where we can start actually calculating the final answer. So, okay, when n is 7, a sub n is 1458. Okay, we get there. Same spot, kind of, just different numbers. But here's what we're going to kind of do here. Notice we have an equation with 2 variables. Notice we have a second equation with the same 2 variables. We can solve this system using substitution. It's a system of 2 variable, or a 2 variable system with 2 equations we can always solve. We're going to do this using substitution. We're going to pick either a sub 1 or r to solve for first and substitute that in it. In particular, it's easiest to do a sub 1. So I'm just going to pick this one just because we can. So I'm going to divide this by r to the 6th, divide this by r to the 6th, and we get a sub 1 equals 1458 over r to the 6th. After we do that, we can take that expression right there and we can substitute it in the other equation for a sub 1. We get 162 equals 1458 over r to the 6th times r to the 4th, and I'm going to write it over 1. We multiply those 2 rational expressions. That's like from last chapter a little bit. R to the 4th over r to the 6th is 1 over r squared. So it's just r squared in the denominator. Now at this point you can multiply both sides of the equation by r squared if you want, or you can turn around and you can cross multiply and solve, whichever way you want to view it, because right now it is in fact a fraction equals a fraction, so you're okay to do that. But right here we get 162 r squared equals 1458. Divide by 162 and you get r squared equals 9. Square root both sides of the equation, right, because the exponent is 2. So you get r equals plus or minus 3, which is weird because we have 2 values for r. But actually there are 2 values for r in this problem. So I'm going to start writing our answers down to the side. Okay? Remember we're looking for a sub 1 as well. We're looking for a sub 3. These are the things we're looking for in this problem. So after that, when you solve a system, when you get one of the variables for solving a system, you take that value and you put it back in to one of the equations up above that you used, we can take this back in, and I know this is going to be crazy, ugly notation. We're going to take that back in and we're going to put it into there. And if you notice, we get, we're going to get a positive value on that automatically, right? Because it's to an even power, it's r to the 6th, and that's an even number. Okay, so we're only going to get, we're no longer going to have a plus or minus for our a sub 1. Okay, we're just going to get one answer for it, which I know is kind of funky. But, so I'm going to do 1458 divided by parenthesis 3 to the 6th parenthesis. And then gives us 2. Okay? So we get a sub 1 is 2. That's nice. So now we still haven't even finished the problem. There's still more questions from this problem. So we need to go back to the wording. We want the third term. We're still missing the third term. So we're regurgitating the same old stuff again. Okay, we're kind of stuck. We'll go back to the model again, and we know what a sub 1 is. We're in good shape. We know what r is. We're in good shape. And we know what n is in this case. It's 3. So we've got all the variables that will evaluate what a sub n is. And that's what we're going to do here in black. So we're going to do a sub 3 equals a sub 1, which was 2, times plus or minus 3 to the third minus 1, 3 minus 1 power. Okay, what you'll also notice is 3 minus 1 is 2. That's an even exponent. If you do a plus and a minus to an even exponent, you're going to both get a positive answer, and the same positive answer. Okay, so for a sub 3, we actually only have one answer for that. So we're going to do 2 times 3 squared, which is 2 times 9, so it's 18. Okay, so a sub 1 is going to be 2, right? We want to find 7 terms, so n is 7. The rate, what's the rate? You multiply by 5, right? You can get that by 10 over 2 or 50 over 10, blah, blah, blah. So s sub 7 equals 2 times 1 minus 5 to the 7th power over 1 minus 5. By the way, I need you to type that in right now. Type that in your calculator and make sure you get the right answer. So our answer is 39,062. 39,062. All right, so let's look at the next problem. Let's just start picking out the pieces. A sub 1, we know it. By the way, this is a geometric series, or series in this case. And a rewording of this problem would be find the sum of the geo series, or find the sum of the series, and then listing the terms 4, 8, 16, 32, 10, 24. That is the same exact thing. So we don't know what n is, but we know that a sub n is 10, 24. We also know this formula. So let's start putting some stuff in that formula. Or even before we do that formula, since we're finding the value of the series, we want to use this formula first, the one up above. So let's start putting things into those two formulas and see where we get. So after we put in the sum equation, we get stuck because we don't know what n is, but we can turn around and find n using the closed form of the geometric series by substituting these values in there and calculating what n is based on. Okay, so don't multiply 4 times 2. We're going to divide by 4 instead, order of operations. So that becomes 256 equals 2 to the n minus 1. So we're going to log base 2 both sides to get rid of that base. Those cancel. So we get log base 2 of 256 equals n minus 1. We're going to add 1 to both sides. Log base 2 of 256 plus 1 equals n. By the way, the 256 plus 1 you can't do by yourself. All right, guys, make sure you get n equals 9 when you type it in your calculator. That's how I typed it in my calculator to make sure I got 9. Okay, make sure that's the case. Once we know what n is, we can substitute it in. S sub 9 equals 4 times 1 minus 2 to the 9th over negative 1. By the way, you can do this a much different way, although I'm likely to push my hand at making you do it this way with logarithms by making the numbers too big to guess and check, or too big to follow the rate all the way through, to find that the 1024 is the 9th term. All right, guys, make sure you type it in and get the appropriate answer as 2044.